Morning, everyone. I'm from Institute of Aeronautical Engineering College. And firstly, introducing myself P. Chethan. I'm from CSE department. My roll number is 219518052. So my topic on TOC is cracking the graph isomorphism puzzle. So how to draw the graph of a isomorphism puzzle? So let us see in this video. So first of all, going to the abstract. Firstly, introduction about the formal definition, and about the history, and about the applications, and about the challenges, and finally future directions. So these are the main points we are going to refer in this video. So first of all, what is the formal definition? Okay, by giving some introduction on the cracking. So first of all, giving the introduction on the cracking of a isomorphism puzzle. So let us check. The graph of the isomorphism puzzle is a fundamental problem in computer science and mathematics. The problem asks whether two graphs are isomorphic, meaning that they have the same structure but may have the different labels on the vertices or the edges. So the graph will be either in the triangle or rectangle, or whether any shape it might be. So it have to be the same vertices or same edges in their problems. Ah, so this problem has an important application in many areas, including chemistry, physics, and computer science. For example, it can be used to study the structure of the molecules, to analyze networks such as social network or the internet, and to design efficient algorithms for solving problems. The next one is formal definition. The graph isomorphism problem can be formally defined as follows. Given two undirected graphs G and H, determine whether existing bijunction between the vertices of G and the vertices of H. such as the adjacency relationships are preservatives than it is for the every pair vertices UV in G. There exists a corresponding pair of the vertices FU or FP in H such that UV is a edge in the G if and only if f of u and f of v is an edge of the H. This problem is known as to be in the NP, which means a solution can be verified in a polynomial time. However, it is not known whether it is the NP, which means that the solution can be found in a polynomial time. This is one of the biggest open problem in the computer science. And next one is history. So the graph isomorphism problem was first studied in 19th century by mathematicians such as Arthur Clay and Camille Jordan. However, it was not until the 1960s that became an active area of research in computer science. In 1982, Eugene Lux developed the first polynomial time algorithm for the problem, which was a major breakthrough since there have been many improvements and refinements to the algorithm. But the problem remains difficult to solve in practice for a large graph. And next one is what are the applications of the graph? The graph isomorphism problem has many important applications in various fields. In chemistry, it can be used to study the structure of molecule and to predict their properties in the physics. It can be used to study the structure of crystal and other materials in computer science. It is used in the design of efficient algorithms for solving problems. One interesting application of the problem is in the study of the social networks by comparing the structure of different networks. Researchers can again sites into how people interact and form communities. This can be useful for understanding social phenomena such as the spread of the information or the formation of the political movements. And finally, the challenges. So despite the progress made in the developing algorithms for the graph isomorphism problem, it remains a challenging problem to solve in the practice. One reason for this is that the problem is known to be the NP hard, which means that unlikely that there is a polynomial time algorithm for it. Another challenge is that the problem can be difficult to formulate in practice. Real world graphs can be very large and complex, making it difficult to determine whether two graphs are isomorphic. Additionally, the problems can be sensitive to the representation of the graphs, so choosing an appropriate representation can be important for achieving good performance. And next one is future directions. Despite the challenges posed by the graph isomorphism problem, researchers continue to make progress in developing the new algorithms and techniques for solving it. One promising approach is to use the machine learning methods to identify patterns in large graphs and to use these patterns to guide the search for an isomorphism. Another direction for future research is to explore the connections between the graphs isomorphism problem and the other problem is in the computer science and the mathematics. By understanding these connections, researchers may be helpful to develop the insights and techniques for solving the problem. Thank you.